Richard Feynman worked on the Manhattan Project that built the atomic bomb. He uncovered what caused the Space Shuttle Challenger disaster when no one else could. He won a Nobel Prize in physics. He accomplished all this with an IQ of 125.
You might think that's a pretty high IQ, considering the standard is 100.
However, 1 in 20 people has that IQ, and it isn't high enough to make it into Mensa, which accepts only the top 2%, usually a score of 132 or higher.
I was an ordinary person who studied hard. There's no miracle, people.
He didn't see himself as anything special, as he said in this BBC interview. But what set him apart was his curiosity. Growing up in Far Rockaway, a neighborhood in Queens, New York, his dad encouraged him to learn how things worked. Young Richard had a knack for fixing radios. His father expected him to become a scientist. His sister Joan followed the same path. Richard gained a sense of humor from his mom. He was a real character, and it showed.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we no, don't laugh, that's really true.
Feynman seriously considered becoming a mathematician, but felt the discipline was too abstract, and eventually switched to physics. He applied to Columbia University, but was rejected. Columbia had a discriminatory policy limiting the number of Jewish students it admitted. He enrolled at MIT and graduated with a bachelor's degree in 1939. He received a scholarship to Princeton for grad studies on the condition that he remain unmarried. The stipulation may have been intended to ensure he fully focus on his studies. He did become engaged to his high school sweetheart, Arlene Greenbaum, but they didn't have long together. She was diagnosed with tuberculosis, an incurable disease at the time. They married on a ferry between New York and New Jersey in 1942 before Arlene went straight to another hospital. She died 3 years later, exactly 1 month before the US detonated the world's first nuclear weapon. The US feared that Nazi Germany might develop a nuclear weapon ahead of them, so the Americans raced to develop the atomic bomb first. The best and brightest scientists signed up for the Manhattan Project, where they worked out of a secret research center in Los Alamos, New Mexico. Physicist Robert Wilson encouraged Feynman to join the Manhattan Project, as he had a reputation for being exceptionally gifted at math and physics. He agreed and moved his sweetheart to a hospital in Albuquerque, New Mexico, where he could visit her on weekends. His work on the project included calculating the energy released from the detonation of a bomb. He and scientist Hans Bethe produced a formula used to determine the energy yield of a nuclear explosive. Bethe used to poke fun at Feynman's New York accent, thinking it made him sound like a bum. During his downtime at Los Alamos, there wasn't much to amuse himself with, so Feynman fiddled around with picking locks and cracking safes that contained the bomb project's secret documents. The documents were originally kept in filing cabinets with padlocks, which Feynman wrote in his memoir were as easy as pie to open. Cabinets with combination locks were later installed, but he figured out how to crack those too. Once, when he visited the plant at Oak Ridge, Tennessee that processed uranium ore to be used in the bomb, managers gathered to discuss a secret report. But the executive who had the document stored in his safe couldn't access it because he didn't know the combination, and his secretary was away. Feynman fiddled around with the safe, and in 10 minutes, I had opened the safe that contains all the secret documents about the plant. They were astonished. The Manhattan Project left a lasting mark on Feynman's legacy, even though he only played a junior role, because he had a hand in producing the deadliest weapon known to humankind. The head of the Manhattan Project, Robert Oppenheimer, was also aggrieved by what scientists had unleashed on the world. I told of his despair and downfall in another video, which I've linked in my description.
Feynman witnessed the detonation while sitting in a truck parked about 20 miles away. He claimed to be the only person to watch the Trinity test without wearing glasses or goggles because he figured that the truck's windshield would protect him from the harmful ultraviolet radiation. Nonetheless, at the last moment, he ducked on the truck's floor as he saw a tremendous flash of light in the sky.
After leaving the Manhattan Project, he was no longer exempt from the draft, but he avoided compulsory military service when he was judged to be mentally incompetent. An army psychiatrist who assessed Feynman wrote these words: "Thinks people talk about him, thinks people stare at him, auditory hypnagogic hallucinations, talks to self, talks to deceased wife, maternal aunt in mental institution. Very peculiar stare. Feynman said most people laughed when he told them the story, but he wasn't very amused and said it was all just a misunderstanding. Instead of enlisting, Feynman accepted a teaching position at Cornell University for $4,000 a year. He wasn't particularly motivated there and was surprised when he got offers to teach at UCLA, UC Berkeley, and the renowned Institute for Advanced Study in Princeton, New Jersey. But he remained at Cornell and decided to develop a new attitude. Why not just enjoy physics? And that's when his curiosity about the world kicked in.
One day, when he was sitting in the cafeteria at Cornell, he noticed someone tossing a plate in the air.
He noticed that the plate's motion was similar to how tiny particles move and interact with each other. In the way that the plate was affected by gravity and air resistance, tiny particles were also affected by different forces. This helped him better understand quantum electrodynamics, or QED, a theory that explains how atoms in light interact with each other through the electromagnetic force. Imagine a baseball game where the baseball represents a subatomic particle and the players represent the force that acts on the ball. Feynman produced mathematical equations that are like the rules of the game. They explain how the baseball, or particles, are affected by the players, or force, and how they interact with each other. He created diagrams that were very helpful for scientists in understanding and calculating these interactions. His curious nature allowed him to draw connections between seemingly unrelated things, between a plate and subatomic particles. For his work in quantum electrodynamics, he won the Nobel Prize in Physics in 1965. He shared the prize with two other scientists who found their own methods for the same problem independently. Many believed he could have won the Nobel Prize again when he and physicist Murray Gell-Mann came up with a theory that explained the weak force, which makes certain atoms change and give off energy. They found that tiny particles called neutrinos carry the weak force and make the atoms change. It's like a game of pool, where the neutrinos are the cue ball that hits the other balls or atoms and makes them move. He never really put down roots at Cornell. He moved from student residences to guest houses to squatting with friends. He reportedly liked to date undergrads, hire prostitutes, and sleep with the wives of his friends. He also didn't appreciate the weather in upstate New York and decided to trade the cold, slushy winters for sunny weather by moving to the West Coast to teach physics at the California Institute of Technology in 1950, where he remained until his death. Before heading to Caltech, he spent a year on sabbatical in Brazil, where he taught physics at a research center in Rio de Janeiro. He learned to speak Portuguese and played the Brazilian instrument frigideira, which is based on a frying pan. He loved playing instruments and also took up the bongo and conga drums. Upon returning to America, he devoted himself to revamping Caltech's physics curriculum for freshmen. He and two other professors transcribed their lectures and turned them into a set of textbooks that went on to sell more than 1 million copies in English. During his early years at Caltech, he also provided a mathematical theory that explains the strange behavior of liquid helium at extremely low temperatures. When liquid helium comes close to absolute zero, or minus 273 degrees Celsius, it turns into a superfluid that does the impossible, leaking through this container. He also studied how electrons behave when they collide at very high speed. He found they act like marbles colliding, in which they can change direction and velocity. This helped scientists make new discoveries in the field of high-energy physics. His work was like a brushstroke on canvas, creating a masterpiece of scientific understanding. He also loved art and took courses in painting and drawing and became really good at portrait sketching. He signed his works with a pen name Ophi, as he wanted the art to speak for itself rather than have people think it was the work of a famous physicist. He wasn't only interested in how things looked on the outside, but the beauty that lay beneath the surface. This is the incredible way he described a flower to the BBC.
I have a friend who's an artist. He'll hold up a flower and say, "Look how beautiful it is." And I'll agree. And he says, "You see, as I as an artist can see how beautiful this is. But you as a scientist, take this all apart and it becomes a dull thing." And I think that he's kind of nutty. I see much more about the flower than he sees. I could imagine the cells in there, the complicated actions inside, which also have a beauty. The fact that the colors and the flower evolved in order to attract insects to pollinate it is interesting. It means that insects can see the color. It adds a question. Does this aesthetic sense also exist in the lower forms? Why is it aesthetic? All kinds of interesting questions which the science knowledge only adds to the excitement, the mystery, and the awe of a flower. It only adds. I don't understand how it subtracts.
He loved to ask questions and think outside the box. That led him to get to the bottom of what caused the Challenger explosion in 1986 that killed the 7 astronauts on board. Feynman was already well respected in the scientific community, but it was his investigation of Challenger that made him famous to the general public. At first, he was hesitant to join the commission tasked with investigating the disaster because he preferred to stay out of anything political. But his third wife, Gwyneth, reminded him of his usefulness. Because he didn't do things the conventional way, maybe he'd spot something others couldn't. She was right. He realized that NASA and its contractors tended to discourage their own employees from criticizing legitimate safety issues. He saw the same type of thing in Los Alamos involving the security of those top secret documents. Engineers at the firm NASA contracted to make the rocket boosters were concerned that the rubber gaskets that sealed the boosters would fail in cold weather. However, there was pressure from NASA, so the launch went ahead anyway. Feynman suspected that rubber gaskets sealing the rocket boosters, called O-rings, couldn't expand quickly enough in cold weather to fully seal the joints, and failed to stop gas from escaping, leading to the catastrophe. To test his theory, he dunked some rubber O-rings into a glass of ice water on live TV.
And I discovered that when you put some pressure on it for a while and then undo it, it maintains, it doesn't stretch back, it stays the same dimension. In other words, for a few seconds at least, and more seconds than that, there's no resilience in this particular material when it's at a temperature of 32 degrees. I believe that has some significance for our problem.
By the time of the hearing, cancer had weakened Feynman. A decade before, he was diagnosed with abdominal cancer that formed a massive tumor on his abdomen, which crushed one of his kidneys and his spleen. Surgery removed the tumor, but he never fully recovered. Near the end of his life, he tried to visit Tuva, a remote region in southern Siberia bordering Mongolia that was then part of the Soviet Union. He wanted to learn about a place he knew nothing about, but bureaucratic red tape prevented him from traveling there. He died before his visa arrived. Richard Feynman passed away on February 15, 1988, at the age of 69. In 2009, his daughter Michelle made the journey to Tuva to carry out his dream. Shortly before he died, the Los Angeles Times interviewed Richard and asked what he was most proud of. He replied, "That I was able to love my first wife with as deep a love as I was able to." After Arlene died, he wrote her letters expressing his heartbreak. "I find it hard to understand in my mind what it means to love you after you are dead. But I still want to comfort and take care of you, and I want you to love me and care for me. I loved you in so many ways so much, and now it is clearly even more true. You can give me nothing now, yet I love you, so that you stand in my way of loving anyone else. But I want you to stand there. You dead are so much better than anyone else alive. P.S. Please excuse my not mailing this, but I don't know your new address." While Feynman may have believed that his love for his wife was his greatest achievement, to the world, his passion and devotion to science was incomparable. Yet he insisted he was nothing special.
There's no talent, a special miracle ability to understand quantum mechanics or a miracle ability to imagine electromagnetic fields that comes without practice and reading and learning and study. So if you say, you take an ordinary person who's willing to devote a great deal of time and study and work and thinking and mathematics and time, then he's become a scientist.
Who knows if he would have scored higher had he taken another IQ test in school. Regardless, he was undoubtedly a genius, thanks to his perpetual curiosity to learn why things work the way they do. If you're curious, just like Feynman, and want to learn about why things work the way they do, Brilliant.org is a free website and app where you can learn math, science, and computer science interactively. My viewers especially love their scientific thinking course, where instead of learning scientific principles in an abstract way, you get to learn through physical insight, like trying to figure out how to make this bridge as rigid as possible with as few beams as possible, or at what temperature the heat should be turned to maintain 100 degrees Celsius. Brilliant's computer science courses are also really popular with my viewers, and no previous coding experience is necessary. I personally like to go through the logic courses to improve my critical thinking skills. Brilliant is great if you're a student or if you're already in the workforce and want to brush up on what you already know. If you ever get stuck, you can click on Show Explanation to see where you went wrong. Brilliant is free to try out if you head to brilliant.org/newsthink. My custom link is in my description, and the first 200 people who sign up with my link will get 20% off Brilliant's annual premium subscription, which gives you access to all of the offerings.